Greeting, everyone, and welcome to the Complexity Lounge, a meetup where we gather to talk about all things related to complexity and complex adaptive systems. I'm Jocko Selberg, and somewhere out there modulating her constraints is the multifaceted, uber-scientific Barbara Frontera, and together we co-host the lounge. Before we kick it off, just a few quick ground rules. We will be recording today's session, so if you do not wish to be recorded, please make sure that your camera and microphone are turned off. After Tiani's talk, we'll have a Q&A period and hopefully a nice conversation with you all. Should you have a question or comment, you can either raise your hand or just send your question directly to Barbara via the chat with a big Q in front, and she will probably just ask you to read it out loud for yourself. The recordings of this will be posted to our Vimeo on the Complexity Lounge page on Vimeo in the next few days, and that is where you can find all of our past videos from the lounge. Today, we are welcoming to the lounge our very own Tiani Jones. Tiani is a longtime practitioner and member of the lounge with a deep interest in socio-technical systems and complexity-based approaches to things such as organizational design, TOC, practice, flow, etc., etc. In her talk this afternoon, Tiani poses the following questions. What does it mean for an organization or system to exhibit behaviors and patterns, or even anti-patterns? Number two, how do these behaviors and patterns connect to these things we call practices? After defining these relationships, she'll consider at least 5 base patterns to look for, as well as some other complexity-informed ideas pertaining to socio-technical systems. So, Tiani, welcome to the Complexity Lounge.
Thank you. Let me just get my slides up here, and then we can get started. Right. All right, do you all see my slides? Okay. All right, so game of patterns. I tried to find a Game of Thrones analogy. There is none in here, but the game of patterns still works for what I want to talk about today. So why patterns? Like, why do I think this is a topic that's interesting, and what do I want to explore here? So some ways that I've been thinking about this, and a lot of the work I've been doing with some of my teammates has been focused on like how organizations produce patterns, and that we've often heard the expression of how every system is optimized for something, whether you know it or not, whether you acknowledge it or not. So like every system kind of like behaves perfectly, I guess you can say. It's like whatever the design is, it's doing that thing. And the behavior of an organization reveals itself in patterns, and therefore we could say that the system is optimized to produce certain patterns. So it's just a kind of a way of thinking about patterns and systems. The other reason why I think it's interesting to talk about patterns is that many organizations will pick practices, organizations and teams, and think these automatically just solve everything. So if value delivery is very slow, or the product's too expensive for the market, like, well, we need some different practices, and that's how we can get to there. So it's not that cut and dry, and that's what we're going to explore in the talk. And so why do I call this a game of patterns? So I was thinking through this, and if you're playing a game like in minimal gameplay, you often ask, did we follow the rules? But if we follow game rules in a game mindlessly without thinking, we're not actually playing. So what I'm proposing is that recognizing patterns is the primary game in complex adaptive systems. So when you play games, there's good gameplay and there's bad gameplay, and you practice in order to perform. It's practice to performance, and you have to look at the performance. The performance is a sign of good play. And so you need to know like what to notice, what to measure to determine if something's well done. And when something is not well done or performance is suffering, a deeper look into the patterns and behaviors generated by what you're doing and how you're interacting could give you an additional insight and awareness. Let's see here. And to bring this to life with an example, well, first of all, just to reiterate that recognizing patterns is understanding the difference between the rules of the game and knowing how to play the game. So the example is that like a few weeks ago, I got back into chess after not playing for years, and I could move the pieces correctly. I could move them, but clunkily. I kind of had to check a little bit. But I would get it if I'm playing against someone who knows how to play very well. Within minutes, I would get a checkmate because I don't actually know how to play. And I felt confused, and I had low confidence and I couldn't recognize patterns, and I couldn't even use the grid on the board. I'd get cornered. But I was moving the rook and the knight and the queen correctly, but my performance was still poor. And I recently saw Nakamura. He's a grandmaster in chess, for those who might know. And he was playing with a YouTuber, a streamer. And after playing a couple of rounds, he recognized what was missing. He told the YouTuber, the other streamer, he was like, wait, you actually don't know the opening patterns. You haven't mastered any closing techniques. That one game we played, you should have won that one, actually. And so that's kind of like kind of brings to life this idea of knowing how to play versus knowing rules. Now that I've laid out that idea in a very like high level way, I thought it'd be important to understand systems, because I've introduced the topic of systems and the idea, what their properties are, like a couple of like lenses for thinking about systems, so we can have a deeper conversation about patterns. So a system is never the sum of its parts. It's the product of our interaction. I think probably many of you have heard this and seen this quote by Russell Ackoff. This holds true for systems generally. It's a sum of their interactions, of the interactions of the different parts. And systems thinking and thinking through, which is the next concept, or like I've mentioned, complex adaptive systems, they kind of get conflated and kind of muddled a little bit. So to start with, like understanding systems generally, steady state systems, they have constraints on the parts. There's interactions and behaviors, generally speaking, in a system that they can be knowable. So for example, a feedback control system, you have proportional control. That's the gain. It's a term called proportional term P has a multiplier known as gain, K sub P, which allows you, it's the easiest feedback control system to implement, which is just that top line. And that leads to steady state errors if left alone. So then you add in integral control, and the integral control adds as a low pass filter that eliminates steady state errors that are introduced to the system. And those are introduced by the derivative control, which is the third line, which allows the controller to anticipate future trend and error. And derivatives amplify signal noise. Noise is a random disturbance on the signal. Mechanical and electrical signals produce these, and they're unavoidable. They happen, and they could be noise can come from your environment. It can come from your implementation. It can come from defects, and they produce shifts in voltage over a variety of frequencies. And then systems have latency. So that's the time delay between when a real world event happens and then the data is fed back into the controller. And this time delays can cause performance degradation, can lead to systems becoming unstable or uncontrollable. So all of these elements interact to produce something, and looking at them in isolation doesn't mean much, but it's how they work together to perform the design intent that's most important. The sum of interactions is key and stands out boldly. So this here is what's called a hard system. There's no human element. And complex adaptive systems, the knowability is only in critical. So in the previous example, there's knowability because there's a math calculation, and you know that noise can be introduced. You know the sources of noise and uncertainty that can affect the system. Usually, in a complex adaptive system, only critical aspects have knowability. So, for example, you can probably know that certain behaviors are present in a system, and based on how they do budgeting, how they fund projects, based on what they incentivize. That's it's a big concept, and you can say, based on what's being incentivized, I can know I might see these kinds of things happening. And if you dig in, you probably will see them. And then you dig further, you'll see, oh, I had no idea this other aspect, what's there. So the parts are less constrained, so they adapt and change in ways that you can't predict. But as Peter Checkland defined a human activity system or soft system, this is what is at play here. It's due to the human element. There's unknowability. And the key concept that comes to play in a complex adaptive system as we as practitioners in organizations care about it is anthrocomplexity. So if you look at like a beehive or an anthill, ants respond to constraints, but how they respond doesn't really change over time. I mean, they might adapt to their environment over time, but if you put ants in different environments, they're always going to build an anthill, their ant mound. They're going to do what they do. They're not self-reflective. But humans, we can change the rules of the game. We can change the dynamics. There's another layer of complexity there. It's not just reconfiguration, it's actually reshaping constraints. And I thought the football is a good example. So humans created football and created these rules and over time changed them and modified like how the game can be played. So there's an official rule book. But what happens in a match now, live, as of now, 2020? Well, referees, as according to the rules, they interpret what they see live. But recently, VAR was introduced, and now a ref can make a call and be challenged by a VAR ref, another referee, which also changes the dynamics on the field between the players and the coaching staff and everyone. There's like some new element that's here, this new thing, but there's also deeper understanding to the game and how they interpret the rule book. There's all this like different level of thinking that happens. I thought that was kind of an interesting example. Another lens or flavor for looking at complex adaptive systems, complexity is socio-technical systems. And this is, there's this white paper, The Evolution of Socio-Technical Systems by Trist, where he made the analysis of socio-technical systems at 3 levels, which is the primary work system, the whole organization, and the macro social phenomena. So organizations that are socio-technical are directly dependent on their material, means, and resources for their outputs. And their core interface consists of the relations between a non-human system and the human system. And the macro-social phenomena was something I found interesting, and I didn't really understand it very well when I read the paper. So I talked with some different people about it, and to kind of understand like what was I missing from what he was describing. And basically, like the macro-social phenomena in some of the examples that he gave in the paper referred to the work that was done in this company in a town, a geographical area where people knew each other and lived next to each other in the same neighborhood, had friendships, and there's other cultural elements. And some of those elements were at play with and influenced the ability for work to happen in this company, in this industry. And if you look at a large conglomerate, macro social phenomena could also be at play within the conglomerate, because if you analyze bigger bounded groupings or the geography, the company history, like they purchased this company, or they let go of this, they sold this piece and like dropped it off. There's culture, there's language. Those could be macro social phenomena. There would be a way to analyze the system. You also see, this is like the realm also, like, talking about Conway's law or the mirroring hypothesis. So someone once shared with me about this company that they worked with, where it was a large company that was everyone was co-located in I think it was in Massachusetts, and they purchased another small company in Maine, and that the small company handled packaging of their data. The main larger purchasing company was often forgot to communicate, often forgot to include folks from the purchase company in the other state. They left them out of meetings. They would leave voicemails and hope they got picked up. I mean, it was just like communication mess. And the product performance was perfectly mirrored in that communication issue. There was data losses and defects directly mirroring that structure. So that feels like another little example that allows you to think through what socio-technical systems, what kinds of things can be at play. Another example, going back to the macro social phenomena too, is that in lean, people thought Americans couldn't understand how lean works, because in Japan you get lifelong employment, and you can pull the and-on cord. But in America, because that's no guarantee employment based on just a different structure, a different legal structure and organizational structure, and just a different system, people might bury mistakes because of low safety and fear of retribution. And so there's another macro social thing that affects an ability for a company to then live into these like lean principles. Okay, so now I just want to talk a little bit about patterns and behaviors and kind of see if I can like tie this all together with an example after that. So one thing that a teammate and I have been playing with this idea of from Westrum's typology, that there's 3 organizational cultures described: power-oriented, rule-oriented, performance-oriented. And then you see some things that tend to happen in those organizations. So we thought like that kind of basically describes like behavior and patterns. So not to go through all of those in detail, but like if you have a power-oriented organization, you may tend to see that cooperation is low, that if you have bad news, or maybe like in the and-on cord example, like if you pull the and-on cord, you're a messenger of bad news and you get shocked, or there's some scapegoating that happens and novelty and new ideas and innovation gets crushed. Over to the other spectrum, you see kind of basically the opposite of that. So this idea that power-oriented is a behavior, rule-oriented, performance-oriented. Now, of course, not every system like exhibits these you might see combinations of these in pockets depending on the size of the organization, but there are ways for you to kind of maybe like identify what's happening. Another way we thought about patterns is that all patterns are just patterns until they aren't. And so consider this outcome statement for a second. If you look at this, it's a lofty statement where leaders could enable a generative culture where technology, products, people, and the operating system continuously evolve to enact innovation in the marketplace. It sounds amazing. Notice the what I pulled the rule-oriented behavior from Westrum's typology. So if you're rule-oriented, you might see patterns such as monitoring and complying. That was the middle bureaucratic organization, where you might see practices like traditional project management, lots of data collection focus, like maybe data rich and information poor. Lots of big upfront design. And then compliance is really important, like stay in your siloed, process information in silos based on like who needs to know certain things. Designing for security, this is kind of like reminds me of like the realm of like safety too, like where information is processed like closest to the data, and like sometimes closest to the information. And in some places you see designs where everything's kind of like cordoned off in a way that it's like we must make it secure, and yet it's focused on compliance versus another way that it could be set up, which I'm going to explain. And so once you say that your outcome is you want to have a generative culture where you can innovate and all that thing, if you find that you're exhibiting more rule-centered behavior across your organization, lots of monitoring and complying, it's likely antithetical to the outcome. And now these patterns of monitoring and complying have become anti-patterns. And so if you consider this outcome statement, again, reconsider the outcome statement, and you want a more performance-centered organization. So you want patterns that are more about like guiding and enabling, which like there's more optionality, there's more enabling constraints to allow certain things to emerge. You allow for evolution of the workplace and innovation as the outcome states. Then you might see like adaptive ways of working, focus on insights, focus on learning, automation, which is like a lot of that is about the levels of abstraction and cognitive load redistribution, focus on value streams, and then designing for trust. So that's the opposite of designing for security. So there's practices that here that there's many options here, but the practices that are centered on these things may more likely create the conditions for guiding and enabling patterns, which means more performance centered. And like we said at the outset, performance centered, good performance is the pattern, which means you're actually playing the game. The main point here is that there's a relationship between your goal and the materialized patterns, and patterns emerge from how you use technology and how we structure organizations, like very socio-technical. And social practice is the integration of meaning, skill, tech, and material. All those things are at play in complex adaptive systems, anthro-complexity. And then, so I wanted to focus on agility as an example, just because I think a lot of us work in organizations that, care about this or are trying this, and what is good, and the idea of what is good performance. So we've established it's not just following the rules, it's understanding patterns, it's understanding what is good play, and there's taste and practice that develops over time. So there's another white paper I found that was kind of interesting. This is just one way of thinking of it, and there's other patterns that we could describe, but I thought these were some interesting ones. So measuring economic progress, proactively experiment to improve, limit work in process, which give you agility. These are the pace of these can keep up with change. The fourth is embrace collective responsibility, which provides resiliency to an organization. And then the fifth expands agility beyond the actor boundary. So I'll just describe these really quickly. So measuring economic progress, it's about a well-formed, evolving suite of measures. So one thing that was interesting in the white paper is that he described how many organizations will measure and report everything thought to be interesting all the way up to executives, but increases cognitive load and it makes it difficult to make decisions. So it's figuring out like what kinds of information is important to which audiences, what time scales, are these like longer term strategic? Are these trend data that allow you to hunt for where things are out of balance? Are they measures that allow you to tell you that something is broken right now? Or just really like intentional creation of measures. And using the ODM approach is one way that I've tried that has been really interesting, thinking through the outcome, thinking through the decisions that you need to make while playing the game, whatever the game happens to be in work, and then what information or insight is needed, and therefore what might you measure. That's one of the patterns around measuring economic progress and what it means to play that game, or to do that well, to perform well. Okay, so then proactively experimenting to improve, that's something that we hear a lot about experimentation and iterative product development, sometimes centers on experimentation, organizational change, and organizational transformation centers on proactive experimentation. But if we just talk about agility and product development, it's iterative. It may involve some experimentation to achieve value. And then change in a complex adaptive system can involve evolutionary as well as revolutionary experiments. This is one thing that the white paper calls out. So one of the things I thought about was the idea between the difference between Kaizen and Kaikaku. So intentional experimentation, intentional leveraging of constraints to see if what you want emerges from the system. And I'll talk some more about that in a bit. And then limiting work in process. I think this is just like it's work started but not finished. It's mentally exhausting. This causes us to mistake activity for accomplishment. It hides process problems and waste that lurks in the system. And if we don't limit work, we can't see where bottlenecks are. And then if we can't identify bottlenecks, we can't fix them. And so there's probing questions that you can ask that when you dive into these, you can then develop solutions and tactics within the constraints that you modify to see that what limiting work in process, what that actually gets you and what you're able to learn from that. Embracing collective responsibility. So there's a lot of concepts like in complex adaptive systems that are underpinning resiliency. So one concept is interpredictability. So the increase of peer-to-peer co-working, co-design, co-creation. And that's not asynchronous work. I think I saw someone talk about like asynchronous collaboration once, and they're like, that doesn't actually exist. So it's actually building together at the same time integrating knowledge at the same time, and know-how and skill and material, using that together, like practicing socially, is part of collective responsibility. At least this is how I've been thinking about it. Deming was also very famous for saying that quality is everyone's responsibility. And in the agile world, we hear a lot about collective code ownership, and that the team is the base unit of value delivery. And resiliency also is the realm of skills liquidity, or debrenting. So if you know, like Brent from the Phoenix project, like he had his hands on the keyboard, he was doing everything, and he had all the tacit knowledge, and we want to spread that knowledge out to others. And so this is like something that once you get those skills that increase learning throughout the organization and spreading skills, you have more resilient systems. And then we've talked about the socio-technical system, solving systemic problems. So that's hunting where things are out of balance. That's like moving beyond the actor boundary. And we know, like, where lean says to eliminate waste everywhere, theory of constraint says to hunt for waste. And so that's like one of those things that comes into play when we get into solving systemic problems beyond the actor boundary. So now I'd like to give an example of a team that I coached. And I'm going away from a software example specifically because I think that we often talk about agility and in product development and technology these days, and we're always talking about software environments. And I think this kind of brings these base patterns and behaviors to life in a kind of like a different way. And so a few years ago, I worked with this team. I just call them the fan team. It's in aerospace and defense. They needed to get funding to design an engine fan from a new material. And they wanted to prove, can this work in real life? And so they were like, let's do this in a new way. Is agile the answer? I mean, they identified that they needed about a team of 5 engineers / rocket scientists. And they were like, well, can we just use SAFe? And I'm like, for 5 people, that doesn't make any sense. Like, why would you use this like heavy framework for like 5 people that just have some questions to answer? So they had already done modeling and simulation, initial calculations, and they said, we think this can work. And they just needed funding. So they had assembled this a year-long Gantt chart with all the usual tasks, dependencies. There were swags at how long each phase would take. And then the leader who was responsible for the effort, he was concerned. He was like, I don't want you to present this to the leaders that we're trying to get funding from, because this sets expectations for how you're going to do this. It's like, this is business as usual. It looks the same as what we usually do. Can't we like explain to them how we're going to do this differently, as well as what we want to do to get the money? And because that might set some different expectations. And so instead of the rigid Gantt chart, rigid plan, I helped them create a presentation describing how they might perform the following experiments. So the workshop I set up was as simple as it possibly could be. Like, I had a whiteboard where they could describe these experiments, and some giant post-it notes with like risks, assumptions, issues, dependencies, open questions. And I was like, I think this might be enough, and we can put this all together and you can actually make a presentation off of this. And so, but they were like, but where do we start? Like, what would we do? I said, okay, what is the question you're trying to answer? And so they thought about it, and they said, well, we want to know, can we make an engine fan out of X material? And I said, so, okay, what would be the first test? They said, well, how would you do it? Like physically, like practically, how would you do it? They said, well, we could get it manufactured over here at this one facility, and we have a lab here. We could put it on the like a rotor, like on a motor, and just like blast it at power and see if it will fail. I said, okay, just write that down. So that was experiment number 1. Here's the test bench. Here's the materials that we need. Here's what we're going to measure. We're going to delay commitment on the blade efficiency design. So basically what they would do is smooth the blades out. Without that, they're still in the mid 90s for efficiency. But once they smooth them out, they're getting to really as close to 100% efficiency as they could. I said, okay, if that test goes well, what's the second thing you do? And they said, well, we would put a housing on it. we'd put like it looks on a plane, that has, you see the big fan moving, and it's there's a plane. There's a big, like tube there, like by the wings. And they said, and we'll mimic that typical engine fan housing. And then secondly, if that doesn't fail, then we'll do the blade tooling it for efficiency. We're going to change a couple other things. And if we'll have proven it at that point. And so they presented this and they received funding. And then once they got funding, it was like, okay, now it's time to kick this off. So I got the team in a room, and I asked, well, how do you typically manage your work? And they described all these different tools. They described like handoffs, and I was like, you're 5 people, you're going to be working together in a lab. Like, is there a way you could visualize, like get a little team room together and put everything up on the wall, like have for all of the work items that you need? And they said, well, no, this is a top secret. We can't put anything on the wall. We can't put anything. We don't have access to Jira or Trello or anything like that. I said, okay. And you can't have a team room, it sounds like, either. So then one person chimed in and said, can we use Excel? So then I was like, oops, sorry. I went backwards. To go backwards. Okay, there we go. So they said, can we use Excel? And I was like, well, yeah, let's use Excel. So we designed a workflow, and then I said, let's just do like to do, up next, in progress, done. Does that work for you guys? They said, yeah, we can do that. And then 2 weeks later, I came in to help them again, and we discussed some of their challenges. And the only thing I really gave them along the way was a little bit of information how Kanban works, some rules of thumb about limiting their work in process. They added on their own some color codings, a color coding system about blocked things. They added and created a system for updating the board in their morning coordination meeting, which happened like 3 times a week. And so that they couldn't really do real-time updates in Excel. It was kind of clunky, but they would kick off the meeting saying, excuse me, like, where's everything? Where's everything at? And they'd move it around, and then they'd have a discussion about what the plan was for what's next. And that was, all what the team just developed on their own. And then the other rule of thumb that I gave them was the other thing that they did was they worked cross-functionally, and they would meet several times a week, as I just described. The other rule of thumb I gave them was look for work on your board that you typically would hand off between the roles, and find ways to collapse it and perform it simultaneously. And if it helps, you can even mark those on the board. And so they started doing that. And what they found is that they would collapse they found that they had a lot of opportunity for things they typically would just hand off in sequence, that they would collapse and do together. And so there was collective responsibility, and they limit work in process. And they had these morning coordination meetings. And then once they got through that end experiment, they had set up an official demo in the lab, and they'd invite all those stakeholders, everyone that was interested in the project, to see how it worked. And they'd look through the data and see how it performed, and really kind of noodle on the problem together. The other thing is that they discovered systemic problems that were within their control. At this point, they were looking for things they could unblock. So one example was there is a sole person responsible for the setup of lab equipment who was overbooked for like a month. And one person from the team would pair up with him and document the setup, and then published it somewhere so that everybody could use it, and actually unblocked other people who needed to use the lab. So they removed this bottleneck for the future, this one person that had this tacit knowledge that and was overburdened. And then the other thing is that they rid themselves of all these review gates. So they stopped inspecting quality in. They didn't have that Gantt chart with these heavy reviews where everyone's kind of looking at the design on paper. They were actually building it, for one. They were collaborating with people, with leaders and interested parties in live demos on the data and the problem versus looking at the schedule. And the other thing that they were able to do because of this is catch a major design flaw early. And one of the lead scientists on the project said that I've worked on a similar project where it took us months before that thing showed up because of how we were working. So we've caught it just through our collaboration, that thing came up much sooner, like months sooner. And basically all of this helped them in record time prove the viability of this material in pretty much close to pretty much a real world application. So if I think back at this effort, like what were the observed patterns? Like what emerged? Like how did this actually work? So we talked about anthro-complexity. Because of that, I can't assume these are rocket scientists. They know how to do the job. If we throw them in a room, they're going to build something. There's no reason to assume that they're going to get it anywhere because of the fact that they have been working under certain types of constraints up till that point, and they hadn't developed a sense of how to control their work. And so my role was just setting conditions to make it more likely that they could be successful. So we thought through some like very lightweight rules and heuristics and constraints management by modulating these constraints, not telling people exactly what to do. And then we stepped back and I said, like, are the patterns we expect to play out playing out? Can we make some changes to these constraints to see if the patterns we want to emerge? And so it was like a minimum amount of process that we applied, which produces better outcomes for everyone in the end. Minimum constraints to get started, and better to start under constrained in this case. And that's called incremental elaboration. And the other thing that we noticed is that every intervention caused a problem. So even when they started visualizing their work, you could say, oh, they can see things better. That's an improvement. But other problems started to happen. Other things happen that then they begin to notice them. They're like, wait a second, I now notice that there's high WIP here, or I noticed that these work items haven't been broken down small enough, or we have this external dependency. And then let's do something about that. And so if we pushed solutions and pushed ideas and pushed practices before the team can observe and perceive what's going on and learn what to notice, then they will become like reliant on me as the coach in that case, or a leader. And so these are some of the things that we noticed by just putting the right constraints in place with heuristics and rules of thumb and checking back in with them as problems occur. And by the end, they were doing things that there's no way I could even predict it. They would have understood how to do those things that help them get to their goal of, can this fan blade be built out of this material? And then one of the rocket scientists, he was like, I remember how we used to work. We just start building until we got it right. And then somewhere along the way, like red tape and standard work came in and we slowed down. And so at some point, standard work makes sense in the organization, or maybe it did, but then it started to be used everywhere for everything, including engineering and R&D. And it slowed down and stifled innovation. So when I think about that, like imagining, or actually observing in this case, research and development being so focused on schedule and scope, it seems kind of mad, because the whole point is to answer questions about design problems as effectively as you can, and as quickly, or effectively, and as with quality and with good design and engineering thinking behind it. Like that's the whole point, not schedule and scope. Not that those aren't factors, but like ever, but just to say that that's not what's in the main focus. Those things are antithetical to the outcome you want. So I'm going to kind of wrap this up in my conclusion. Everything on the slides I say is kind of like the same thing from a different angle. And I wasn't really sure how to consolidate it, but it's just how I'm reasoning out these concepts in my mind, like how it all ties to complexity. And I really love like Demian's quote, I make no apologies for learning. So if I say something that you want to challenge and talk about, like, that's great. So one of the things that I thought about was this idea of bounded applicability, also requisite applicability, which I think was the term that I remember hearing this first time when in Dave Snowden's old Cynefin video from YouTube. The thing that I have thought through a bit in working with other teammates and colleagues is like this addiction to practices as a silver bullet, as solutions to all problems, and we drift. We talk about this and we say, yeah, I get it, but we often drift and like start getting away from this. The idea that interventions can cause problems, but the point is to learn and build skill about what to measure, what to notice, what tools and what practices and techniques to employ at a given time. And how to notice that, oh, this is not moving us in the right direction. Let's tweak this way and tweak that way. All centered on a desired outcome, that relationship between your goal and the materialized pattern. And Jay wrote this in he had Jay Bloom has a post that he wrote about this where he said that failure to recognize the bounded applicability of our tools results in less effective utilization of our tools. So if you use the wrong process for the wrong problem, you lose confidence in the tool. And then that tool could be useful in other domains for other situations, but now you're going to avoid it and just say, no, it doesn't work. And so it's about developing capability for teams to sense which domains that their work falls in, the capability, but also the capability to operate in and an understanding of which practices and guiding principles to work in the domain. Again, that sense of taste and practice that will most certainly involve modulating constraints. Oh, there's the blog post. The other thing that I was thinking, like learning how to play well. It's performance is a sign of good play, and knowing what to notice, what to measure is part of playing well. And part of that is recognizing the patterns, understanding the difference between the rules of the game and playing the game. So, if you like, for example, if you try Scrum or XP or these other practices, but leverage them as constraints in order to observe and notice the patterns that emerge in your context, then you're using them well. Forced versus as like forced order or like a set it and forget it. You have to like tune them to what you learn. Always want to maximize learning. And then the last thing I thought of was that awareness of anthro-complexity in socio-technical systems, it also changes our expectations. So I think it changes what we expect of ourselves. I think it changes what we expect of others in product development or if you're in consulting and coaching, because practicing socially involves this integration of like I've said, like meaning, purpose, skill, tech material. We can't always, that integration is unique to every context and to people, how they integrate new knowledge. And we can't expect each other to always have the answers once we understand how complex adaptive systems, human soft systems work. We can't always expect people or expect ourselves to get results. Sometimes we won't get the results. It's about what's really important is maximizing learning, creating the conditions for learning, leveraging practices that make it likely that we can learn, and then tune from there to magnify learning. Can't really stress that enough. And then a brief anecdote to just explain it. This is like bringing it all the way down to a team. Very early in my Agile experience, a tech lead was on the verge of firing a young developer and called him a poor performer. After they did some team training and XP, and then they tried it and experimented with it, this lead, they tested pair programming in particular, rotating pairs. Well, the lead noticed that this young developer began to flourish in this new collaboration format to the point that the lead thought he was a whole new person. And in fact, the constraints had been modulated in such a way that this team member and the other members of the team could learn together and produce together, learning through doing and building together versus he was getting assignments in isolation before. So there's a human level to all this and what can make work better for everyone. So yeah, that's what I've got. And thank you all.
Thank you, Tiani. That was great. I mean, I will say that I do like a nice Gantt chart. So, I mean, they can be very appealing visually. I was really starting to understand the connection with anti-patterns there, and that was very helpful to me. So, questions. Do we have any questions from the audience? Amitai, you had an interesting, this bounded perfection idea is interesting. But we'll maybe get to that. Shasta, you have your hand up.
Hi. I was wondering if you could explain a little bit more about limiting work. You had mentioned it both in the fan in your slides and then the fan example, and you said that also when the team had like too much work in progress. Yeah, I don't just a little bit more on the anecdote of that.
Yeah. So the team would usually, well, their original plan was to describe all the activities that they could for building this fan, which they couldn't actually do that, but they would try. And the typical way of working was to have this, dependencies Gantt chart, like with all this work kind of laid out. Once they flipped to this more like experiment 1, 2, and 3, the work was all centered just on, in order to test, can we put the blade on in the lab? It was a much more simple breakdown of what was needed to get to a produced fan assembly in the lab. In addition to that, they wouldn't, because of the fact that they were finding ways that they could pair up together, they weren't just throwing a bunch of things in progress. That was one of the things we talked about in one of the coaching sessions. They'd say, okay, here's all the stuff at this point we think we need to do. If we kind of loosely rank them, these would be this set of like 4 or 5 things that start with that, and they'd move that to up next. And of those, they'd move a couple into in progress. And so at any given time, they had maybe like 1 item roughly per person, something like that. You would never find like 100 things in progress, for example. So they would be like just focusing on a limited amount of things they're trying to get through, understand, and once those are complete, then they pull new things over. So that was like a key part of limiting work in process. It allows them to get their arms around the work and also notice where things are getting blocked, and gives them more opportunity for sharing work as well, because they're not trying to juggle too many things. And I think it was like Mary Poppendike who described it in one of her papers. She calls it when teams try to do too much work, it's called a quasi-simultaneous operation. So basically value is not delivered very frequently because you're chipping away at like multiple things versus a smaller set of items where you then start to see value or you learn from it, and then you can like pull the next bit of work together. So that's some of the things that we played with the team regarding limiting WIP. They didn't actually use WIP limits. They were 5 people, and they kind of, in the beginning, that concept was like too much for them. They just couldn't, they didn't have a sense of taste or practice or around limiting WIP and using WIP limits and kind of like advanced Kanban topics. So the rule of thumb was loosely an item per person, or at least pair up on things, and don't pull too many things over until you've actually completed something. And that was kind of it. And they just used that and had that conversation happening in their little morning meeting. So they kept themselves in check that way. So hopefully that gives you a little bit more flavor of how they did that and what was important.
Thank you.
So Michael, you have your hand up. Michael Chevalier.
I do. Thanks, Tiani. When you talked about learning, obviously, I was kind of curious how you facilitated or how you supported the team in learning. I mean, there are only 5, and your example of spotting an issue or that situation a lot earlier demonstrated huge value. I'm sure the learning and the interaction of 5 is one thing. So the 2 questions around, the next 2 questions. One was, how you facilitated learning and how is it different from before? What interactions facilitated capturing that issue early on compared to how it maybe would have done before? And did that propagate to actually changing and consideration of thought where you've got much larger teams than 5, right? Or teams of teams?
Yeah. So what things facilitated it? Because we did some retrospecting along the way, along those things, because this project went viral, by the way. And they were like, we have 12 other teams that have all this other technology development we want to do. Can we duplicate this? So what facilitated it? One, they had their operating rhythm was one thing that facilitated it. That they weren't used to doing like a really, containerized like morning, almost like a stand-up, but when they had their Kanban system, they would update it because it wasn't like real-time updates or anything. They'd say, okay, where's everything? They'd move it around. Okay, what did we learn? What's happening? And they were so focused, they were focused more so on the problem solving than a schedule. So it was their operating rhythm, and then they're focusing on the problem solving. And then I also think it was the chief scientist, he said also because they didn't do those handoffs and they found those opportunities to collapse their work and design together. They were able to like simulate some things, design some stuff, test something in the lab, go back and run it again. And they're like, oh, wait, there's a problem. And because of that, build and learn and measure and test and work together collaboratively, those were some of the factors I think that were at play. At least that's how they reasoned through it as they were noticing that difference. Well, interesting question about something for bigger teams. So this was like a new technology development. That fan blade now has to get integrated somewhere. There comes bigger teams and bigger parts of the organization. The fact that they were able to iron out this, at least that technology development, and come up with this new system for that. Now the thing is like, how might we, like, what are the constraints we can modulate to allow us to now integrate these new technologies into our existing, engines, or for new engine design. That was the next thing that naturally came from that. I didn't do a lot of coaching with the team after that, but those were the things that emerged, and those were the opportunities for now saying, what can we play with to now be able to do that more effectively.
Cool.
I think I saw someone else's hand up a second ago.
You come and go. I mean, I'm very impressed that okay, so there's Jocko's actually raising his live hand, but Maru is first. So Maru, am I pronouncing that correctly?
It's fact-proof. It's been designed that way.
Okay.
It's a shortcut for my rename.
Okay.
TDD all the way. I have a hybrid question, so bear with me, Tiani. Could you give examples of definitions of done or the equivalent thereof that they've used? And the pendant to this question, the other side of the coin, I'm sorry for the double question again, but I promise you it's related. So the definition of done examples is, do you have an approximation or a feeling for the percentage, the reduction in percentage of handovers? So minus 70%, minus 5%, compared to how they used to work before. Thank you.
I don't think I got the first part of your question, but the second part.
They used to deliver work items, working on them individually, right, and then hand them over. So they must have had a definition of them, whether it was explicit or implicit, but somebody,
I see,
chief engineer, must have had it. So when you introduced them to that new way of working, what has replaced it? When did they know that as a pair or three or whatever, they were done with something and they could really move on to the next piece?
That was based on so they were typically following loosely, I would say, kind of like a V model engineering process before. So I don't know if they have a formal definition of done, except for like, did they answer some design questions? And so the design questions as they arose were at the forefront, which is allowed them to, either someone would take something and work on it because it was like in their discipline or in their focus area, or they'd pair up. And so really it was just focused on, do we understand this aspect of the design, whether it's around the blade, other kinds of, efficient, the efficiency, the power required, all the specification that was there. everything was centered on that. So that's pretty much like, that's probably as detailed as I can go with like definition of done. There was no like formal, like, here's what it means to be done, other than did we answer these questions. Regarding the percentage of how much less handover did they do, I don't know if I have an answer to that. I don't think we didn't have data on how much less, other than the fact that it was like the way they worked before. Like it's the only way they worked. They would say, okay, my piece is done, and now I'm going, and it would maybe be, someone would pick it up and they'd work in a different tool, because there's different simulation tools. They didn't really have like a digital thread or anything like that for their design. There was no data thread. And they would always do it like in their cube somewhere. So it went from 0 to something is pretty much how and based on their the fact that they were doing these like collaboration sessions 3 days a week, and then figuring out how they're going to collaborate between the next cycle. So yeah.
Was there maybe an oracle, some authority figure in the team that could say, okay, this is good enough, move on?
There is a lead the chief scientist, the chief rocket scientist, I guess in this case. He was the authority on all things design and specification, technical specification.
Process-wise, would they like have to cross him before something could be considered done, and then we can move on? Was he the bottleneck?
I wouldn't call him. I wouldn't say a bottleneck,
no.
because he was building with the team, but he would have some tech leadership, I guess you could say, for sure.
Okay, got it.
Yeah.
Thank you very much.
Okay. Greg, you can't just say something like that in the chat and not expect me to ask you to weigh in here. So, go to it. Come on.
Hi. The question was really about basically the evolution versus emergence. So what it struck me is basically you're looking at it from an evolutionary perspective, but does it allow for emergence at all?
In the team example?
In the fan example, probably not, but in the more general sense.
So what specifically are you saying allows for emergence versus?
No, I was just wondering whether you've thought about it. So it's touching on sort of Kaufman's basically adjacent possible. We don't necessarily have the concept of we understand the direction. Agile, Scrum would typically be more complicated because it can treat evolution, but can it actually treat with emergence, and how do you deal with that?
Yeah. Okay. Yeah. So I think it depends how you're leveraging the practice, is one way I've been thinking about it. So if you try to, it's kind of the whole, if you use, for example, let's say Scrum, like as forced order, like do it exactly by the book, and then that means you're doing it well, then that what happens then is you may be over constraining in some way. And what that does is you may see some changes and shifts, like the practice may have some, like it may evolve in some ways, but what you're looking for is what emerges in your context that allows you to go towards your outcome. Like you're always tracking back to your outcome. And so if you use a set of practices or a practice or framework as a set of constraints, and then you sit back and say, what's happening? What things are emerging? Are things emerging? Then I think that's kind of how I think about it. But I've never really compared what, the concept of something evolving versus emerging. Evolving might mean this like Scrum, you take it, for example, and it, there's a new flavor of it, I guess. versus some new thing arises that's bespoke to your environment that helps you achieve your outcome. And it doesn't sit in the Scrum rule book. It embodies a pattern, like, I don't know, collective responsibility or a limiting WIP. And you can't find it in the rule book anywhere, but it's something that you do that helps you achieve your outcome and that makes sense in that environment. Maybe that's kind of how to think about it. I don't know. That's an interesting question.
Well, it comes back to the outcome, because I think that in itself becomes a constraint.
That's true.
I wrote it was an InfoQ paper I wrote about a year or so ago. I think it goes back to about 18 months. I looked at this and how you could actually, because it was very much more an evolution, an emergent problem space that I was dealing with that one. And I think this is one of the problems we get with Scrum. You know, if you've been frank with Scrum goes back to 1995. It's nearly 30 years old. In fact, its history goes back to the new development paper, which was published in the mid-80s. So you've got a practice which is effectively nearly 40 years old.
Yeah.
Surely we should probably be moving off and finding something that actually can embrace both emergence and evolution. And I think it's something that people like Adrian Brown and Mike McMasters have been exploring, or starting to explore, in their writing recently.
Yeah.
But thank you.
Thank you.
Okay. Jocko is bouncing around in his chair and typing in all caps in the chat. So I'm going to ask him if he has something to say right now.
I had to misspelling as I go along. I was going to ask a question, but Greg has made it slightly more complicated. I was going to ask a very vague question or general question. There seems to be a theme here a little bit of stability in these systems, the behavior, the patterns, and the practices.
Yeah.
And what we mostly see, going back to our earlier question on WIP limits, essentially what I see going into most of these systems is a thing or things have destabilized the system, and before we can actually do anything with it, we want to stabilize it. That's usually why we impose WIP limits or whatever we end up doing in order to stabilize the system. The reason Greg's question throws a little bit of a problem into this is you oftentimes want to destabilize the system to allow for emergence or evolution. There's slightly different terms there, but to allow something to happen that's different, some novel thing to happen. So going back to, now that I've sort of dismissed Greg's take on that for the moment, I'm coming back to the stability question here. Seems to me that part of the reason you're modulating constraints is to either amplify a particular stability that you have or want, or to move it somewhere else to a different attractor basin, let's say. Complexity terms. But it's something that I noticed spread out throughout your entire presentation that was unspoken, perhaps, was this stability question. And I was wondering if you wanted to comment on that.
The best way for me to think through that one is if I take the team example again. So when the team got into the room to say, okay, we got funding, you helped us with a better presentation so that we set expectations that we're not doing things typically. We talked about, we're going to try to work a new way, and we're going to try to solve this problem. We're going to try to solve this problem in a new way that we don't typically work. They just kind of sat there and were like looking like, what do we do? The level of uncertainty, I felt that to be like, it's unstable. Like if we just left them in there, who knows what would happen. So that's one way of thinking of it, is that the constraints that we played with helped them have a thing they could start with, and we gave them a lot of flexibility. I gave them so few things to do that I kind of wanted to see what things would go sideways, and it was safe because I was coming back in a couple of weeks. And so from a stability standpoint, the organization around them had created a space for them to be able to do this as well, while other stuff was still happening according to like business as usual. And then once they learned from this, then they were like, well, how can we do that everywhere? But it would require, again, creating some kind of like boundary to allow for actually instability of some kind, question, uncertainty, confusion, and playing with constraints to see if it allowed them to solve problems in this more effective way, where they have interpredictability, where they have cross-functional design and engineering and high communication with users and stakeholders, building things live versus all designing in digital tools, all of that. So I don't even know where this conclusion to that idea is, but that's kind of how I think about it. There's this pocket of where you're able to create something and it's not really stable on purpose. And then you start to introduce things to create emergence of these new patterns.
Yeah, you're playing with the stability, instability. You're doing it somewhat consciously, but you're also seeing what comes out of it. And you use your constraints to kind of keep a handle on it.
Yeah, I remember I worked back in the day when I worked at ThoughtWorks ages ago. I were this team that was dropped into this client space to be the first team to do a lean startup project. The client had been reading the book and carrying it around with them, and the team was like, what do we do? And these are teams that are like, when you put like a ThoughtWorks team in the room with a client, they're like, kind of like the ant example, like they set up pairing stations, they get stand-ups going, they start doing stuff on the board with the whiteboard, and like having retros scheduled. I mean, there's things that just kind of happen because they're trained and they all get that and they know how to do that together. Even that team was completely uncomfortable trying, like, wait a second, we're going to build for a couple of days and then go test it live with people. But what are we working towards? Like, what's the timeline? Even with this team that was used to working completely in this like iterative way. And I remember like the client principal in that case said, we need to get comfortable with being uncomfortable. So I thought that was kind of like an interesting way for him to say that. But we were like in that process that we developed to build this thing, developed over time through all kinds of uncertainty with like whether we're solving the problem, like how do we actually do it? Like, did we actually learn what we needed to learn from the people when we tested the thing live? And, do we need to have we learned enough now that we can actually roadmap some things out versus just like build, measure, learn really rapidly, and all these things that like, and over time, a framework that completely bespoke set of things that were being done emerged out of that. But again, it was an organization that created this like team room and this project and the kind of bounded, like kind of like this bubble where they could do that.
Yeah, you want to be comfortable with being uncomfortable, but you don't want to be freaking out. So you need to bound that and then modulate those constraints as the system goes in whatever direction it goes in.
Yeah, it allows you to also be more like able to notice things too, because you have to like have the right level of, there's something around like security and safety and being able to like chip away at a problem in a way that allows you to think creatively versus being in high stress too.
Yeah, and you pull in the multiple identities and all that kind of stuff, right?
Yeah.
They're going to react at different ways and different times, blah, blah, blah.
Yeah, exactly.
Cool.
Okay. I don't see any questions, but Andrew, you're the first one who put a long thing in that I don't want to read in the chat. So if you'd like to talk about either the evolution comment or the earlier one about the difference between specialization and...
Yeah, we have a raging side debate about emergence and evolution, which is a whole big topic.
Yeah.
So I'm being careful not to go off shooting in that direction too far.
Yeah.
It's an interesting topic, but it's a big one.
And then Marissa has her hand up after this, but go, Andrew. You had that in the chat for a while.
Yeah.
Well, I can wait. I'll formulate an intelligent way to approach that topic, or I'll try to.
All right, then we're in trouble. I know what it means when you say you're going to take your time and formulate this. Marissa, you had your hand up.
Thanks. Yeah, and I don't know if I formulated an intelligent way to say this, so but
it's the complexity lounge. Whatever you say is fine.
Excellent. As I'm thinking about like emergence and that whole conversation, emergence versus evolution, like where my head goes is scaling, and that's probably because of where I come from. My job is transformation agent in a large company to help them to transform, and so like all of these topics. And the whole complexity of the socio-technical systems that we're in make it difficult to transform. And so Tiani's like the whole story that you shared of that fan team, I'm thinking about like, you said, okay, like they even said, this worked really well. We have like 12 other teams we want to do this in. Like, let's, and it went viral. In my experience, a couple of things happen. Either people try to scale too quickly, or even like the concept of scaling, every time you take a situation that worked really well here in some boundary, some subsystem, when you try to apply it somewhere else, that this new place has completely different conditions, different context, and the humans in there are part of that. Like, because a lot of times the way that we work, the processes we use, the interactions, whatever the system we're in, makes us feel safe, because even if it's not the most effective or efficient, it just feels safe because we know it, we understand how it works, or we think we do. And when we start interjecting like new ways of doing things, it just makes people very uncomfortable.
Yeah.
And so the humans in this new place that we're trying to apply it aren't going to just accept what happened over here in that whole not invented here syndrome of like, we don't know if we believe it yet. And so like, I'm going to use the word scaling, like scaling what worked well somewhere else is just very, very complex. It's very, very difficult to do. And it's not very straightforward. And I don't know if that's related to evolution and emergence, but where my head goes in the very big picture of things is like my job as a transformation agent, I don't know if I'll ever see the result. I mean, I work for a company that's 110,000 employees. Like, I don't know if I'll ever really see the results, but I'm hoping that I'm planting enough seeds that like when the younger generation that's experiencing these new ways of working becomes the VPs and becomes like, that's just the way we'll do business. But it just feels like it's going to take a really, really long time. So it's not exactly a question. It's just where my head was going with all this conversation. I wanted to throw it out there and get reactions.
Yep. There was something that you said around the scaling part of it. So if we were to take like this fan team and then say like get the other 12 teams working in a similar way, like if you could say like because of the framework, call it a framework, that the loose, like here's how you do a kickoff, here's how you might do a kickoff, like have these elements, and then here's a way that this team visualize work, here's some other options, but have help. Every one of those teams, because they were all around research and development, is going to run into the next thing, which would be, wait, but how do we integrate these new technology, these new elements into a thing, and aircraft, for example, a new engine for aircraft. So that if you can create a system for like answering those, how might we next do that? I think that's what I was really hoping with this project to take to the next level when I was working on it. And there was something else that you said. The idea flew away, but there was something that you said that was really interesting around the scale question too.
Did that happen for them? Like, were they able to scale it?
They were able to try it in other pockets, and it was like less focus on this, like less focus on these schedule, getting people in a room and just working on problems that they can solve bit by bit. It didn't become like this large scale, like across the organization, all the things, but that's fine, because for new technology development for this center of like 300 or 400 scientists, that was a big change. That was like a big step forward. And then here's the thing. One thing they didn't fix is that because of the way they were doing budgeting and funding in this organization, I remember some of the engineers were like there were 5 people on this team. On paper, it was 1.5 people because of the charge codes.
Yep.
So that's one thing they didn't solve yet.
Yeah.
But we created a situation where we could now talk about that, because before we couldn't. Because by the way, these problems might have. Why can't we test that this problem could have been a problem like this could be solved, more effectively if we could dedicate the team? Or what would it take to do that? Well, they're going to run into some big system problems then.
Yeah.
But they're able to now have those conversations because they've showed some progress in a certain way. So, yeah.
So maybe I think what I'm taking away from your response is like tell me if I'm thinking about this the right way. Like when you started off and you were talking about patterns and, playing the game, understanding the rules versus really being able to play the game, like some of those patterns maybe are what you were describing there of like, here's a kickoff, here's a pattern that works well for kickoff, and here's some of the things you need to think about, and here's a pattern for, XYZ, whatever it might be, giving status in a new way, or presenting your plan without a Gantt chart. So what you did with the first team was basically establish new patterns. Am I thinking about that kind of the right way?
So new patterns, they played with some, I would say, practices that would make it likely that they would have these new patterns.
Okay.
So, and what we did see was shared responsibility. We saw unblocking problems and, going and finding a solution to things that were like beyond, when that person with the lab set up, for example, they went and documented that and published it. So now anyone can set up the lab safely. Things like that. We saw those things kind of emerge, and those were patterns that you saw the team consistently do over the 6 to 8 months that they worked together on. I think it was 6 months they worked together on this project. Okay. They had more like enabling and guiding type work patterns there that were tied to the practices that they had been trying.
Okay, cool. All right. Yeah, thanks.
Versus monitoring and complying, which is what they were focused on before.
Yeah.
Okay, well, Kyle has had his hand up for a while, and then I have a question from Clark Stacy, and then we'll see, Andrew, what you've come up with. So go, Kyle.
Cool. Thanks, Barbara. So 2 things. I've been trying to articulate why like Lean and Six Sigma don't work for everything, and you like summarized it in Humans Change the Rules of the Game. Like I've pontificated for hours, and I think that just nails it. So I wanted to put a highlighter on that. I don't know if this is so much of a question, but you got me really thinking about the noise in the system, and we've talked about that before, and I've been spinning, and that in relationship to pattern recognition. And so your diagram with the low pass filter, I love, but we usually think in those terms of noise as being single source. And that's not necessarily always true, especially in a complex system. It's probably absolutely not true. And the difficulty in identifying the difference between noise and the medium that we're working with is also really important. In a electrical system, it's all additive, and it's modulating for a single signal. But in a complex system, in a human system, you got me thinking about how noise is actually modifying behavior or modulating behavior. And so there's this harmonics, essentially, that ends up happening internal to the system. And so with it being as random as it is and creating these patterns that are resonating through multiple agents in the system, how do you think about pattern recognition when you've got multi-source noise modulating multiple agents?
I think if you go back to the slide I had on the complex adaptive, was it that slide? Yeah, with the knowability aspect. So one, okay, there's two things. If I think about just if I use like Westrum, for example, and there's three like pattern behavior and then a bunch of patterns there. And so I know if I see this pattern, I might be looking at more like a pathological culture thing going on here versus like bureaucratic versus generative. If I many organizations have like combinations of those things. So that's one thing to just know. You can kind of know that that's probably, it's like you don't go to any one organization like they're all, I mean maybe there is, but I haven't worked in organizations that's like 100% just like this is a pathological organization. They may exist, but I might see pockets where I see collaboration and like generative type stuff happening, or like someone innovated something and it got, and a new idea did something cool. So that's one thing I think about. And then also, if you think about the knowability of a complex adaptive like human system, only those critical aspects are knowable. And that's why we kind of use the complexity techniques of like experimentation or probes and bounding things and seeing what we can understand, and testing where we can, because of the fact that what you think you might know might not be true. And that goes, I think, for patterns that you think you understand, you may understand or not understand. That's the thing. That's how I think about it.
Okay, that's connecting to what you were talking about, raising the awareness for change, essentially. That new sensitivity to when things were changing being really important. So yeah, I love that. Thank you.
Yeah.
Okay, well, first Jocko said something in the chat that I will not read right now, but first we'll go to Clark's question, which is, how much diversity, conflict, and creativity was there within the team? And did the solution turn out exactly as they originally thought, or did a new version of the idea emerge during the process? So let's start with the diversity part. I mean, this was a bunch of science guys, but
yeah, we had a couple of different cultures, different ages, different backgrounds in engineering wise. So there's like, some diversity on the team. From that standpoint, so looking at problems in different angles, there is I can't ever tell the story without laughing, because there's one young guy that he was the one who updated he was his job to update the board, and he I guess he had just like quirky way of doing it, so the older scientists would be frustrated with him all the time, but it was in this like kind of fun way. So there was conflict. There was probably some I didn't see, but I would always get notions of the conflict, and it would happen when I came in for the coaching sessions. And one of them, he would get yelled at, but not like yelled, but like in a nice kind of a funny way. But there was conflict around the design, around the learning, around, obviously there was conflict when they were like stuck and they had a bottleneck and like, we can't get into the lab and it's going to blow up. It's going to blow up our project unless we find a solution. A lot of the conflict was really centered on more so on the problem solving, because they had this really simple system that they could follow. So everything was, all their cognitive load was like really focused on the problem solving versus all this like updating, doing what they had, this like heavy stage gate approvals and documentation that they would have to do, and some spreadsheet with some bowler chart metric, red, green, yellow, watermelon chart. Like they didn't have to do any of that. They had to demonstrate in the lab they could show their little their Kanban system, and they could show their calculations. Like that's it. So all of their brain power was focused on the real more important stuff. Let me try to see it, like scroll back up to see other parts of the, because the solution turned out exactly as they originally. So the solution ended up being very close to their simulations, but just they had like actually physically for in real life developed it. They by the third test, the blade was the whole blade assembly was what it would look like if you were to like, you know, drop it into an engine on a plane. There were some little tweaks, but they were like on a lower level, like engineering level of stuff that I didn't track since I wasn't working on that with them.
Okay, I think that answers that. So Andrew, what do you got?
Hi, Tiani. Thank you so much for the talk. So one of the things that I'm interested in is utilizing Westrum's typology to kind of try to change a bureaucratic system into a generative system. And any experiences you've had with that, and I can contextualize it a little bit. Because one of the things I'm really interested in that it sounds like you've dealt with is working with learning and emergence within budget constraints, and how you kind of approached, you know, teaching a system to actually investigate that and make some intelligent decisions around that process. And the idea that, you know, schedules and defined processes like Gantt charts, they don't know anything. So kind of focusing more on the sense making, the knowing within a dynamic system or a set of systems. That's kind of the framework of what I wanted to bring into the discussion.
Yeah, a couple things come to mind. So there was another team I was coaching in that same company that was building a model-based digital thread. It was about 30, again, scientists. I get, you know, some of like the lead had hired some people from like the leading experts in this concept and this idea. And the way that, I don't know if I use Westrum exactly with them. Sometimes it becomes a little bit too, it might be a thing that I use as like a dark scaffolding thing versus like putting it right in front of the team, but helping them notice a pattern of where they're focusing. In this case, what I used was helping the team. I tweaked a couple of things of how they did their planning. And I took away a lot of the stuff they were doing before. So kind of like slightly under constraining. So they began to notice that they hadn't been focusing on the problem. They'd been focusing on a bunch of ideas versus they had a set of users, a program of engineers in front of them who had some issues that they could start to chip away at to help to get them towards being able to have a data thread. Because they would notice then that they were kind of like in Star Trek Next Generation in their team and their ideas, but the organization was kind of the original, where it's like, that's 300 years in the future and it sounds awesome, but I don't know how to get there. Like, it's kind of that whole, the whole idealized design. If you think of like Jabe does that whole like ideal present loop, where you think about like the ideal future and you sit in that ideal future too long, like you don't even know how you can get there. It's too big. But if you can think about a step forward, an ideal present, and you know, what can we do with the conditions that we have now in our current context that can avoid some of the problems or like fix some of the problems we've got, avoid that get us directionally towards the future, and avoid the things we don't want, then that's better. So they actually, based on the little few tweaks we made to how they did their planning, the day one of planning, at the end of the day, they were like exhausted and like, we don't have any ideas. We haven't made any progress. We don't have like the next iteration outlined. And I was like, let's walk through what you've done. And we walked through it. And they were like, and even the lead of the team was like, wow, we just brought the problem space higher up in our conversation than we ever did before. And now we have to like figure out like what are the problems that we need to focus on and like zoom in on. And that should lead what we plan for the next cycle of our planning. And before, they were just like trying to do all the things, but they didn't notice it before. They didn't notice that before. So it was like creating some conditions for them to notice that pattern of focusing on all this ideating versus like prioritizing and streamlining it on the problem they wanted to solve. So that's one that came to mind around that. I know there's a second part to your question, but I can't remember it now.
It was basically just helping the organization to embrace that on like a meso scale.
Yeah.
Things like budgets and, you know, kind of how to operationalize that in some way.
So the thing that I played with there is actually trying this out in a couple of weeks, doing actual pattern mapping with a group. And we actually had them source patterns that they can notice right now. And once they do that, then we can talk through those, like what are those patterns and like where might they be coming from? It almost reminds me a little bit, it's like a baby step into, if you've ever seen the documentation on the large scale Scrum website, there's like a whole section on like focusing on systems. And he I think it's Craig Larman, he does this whole drawing about that shows like if you hire less expensive developers and you have lots of bugs, and then you have like less expensive developers, and you don't have any mentorship and training program, and then like you draws this whole like little complex like notation that shows that like reinforcing feedback loop to why they actually have a lot of bugs. And then you can talk through, okay, well, what if you just tweak this thing here and now have like mentorship and pairing and this kind of thing? Like over time, could you see that maybe bugs start to go down? Like creating like awareness is, I think, a place that's really important. It really thing that you can is really important. And there's different techniques to do that, whether it's like you creating a current reality tree, doing a rich picture map, like using systems methodology, using we're just like trying this bespoke pattern mapping technique. Wordly mapping, doing the doctrine analysis can be that where you can kind of like evaluate as an organization, like how do we do these things? And therefore, what might we do to enable the strategy that we want to deploy? There's like so many options, but it's all about, I think, helping teams to gain awareness through some kind of like activity where they step back and self-reflect and then figure out what are the constraints that they can modulate and play with in order to get towards the outcome that they want. It's not always easy because of pressures to deliver, but if you can find a way to kind of interrupt and get time to do that, it's really helpful.
Awesome, thank you.
Okay.
Any other questions?
Any other questions?
Comments?
I mean, I must say, Marissa, that scaling question bedevils everyone. Because yeah, Jocko's just clutching his head. Yeah, and I think that part of the problem is that if you go into a sort of experimental mode that Tiani's describing with the scaling question in your head, it kind of short circuits the process.
Yeah.
And so, I've had clients say, well, will it scale? And I'm like, I have no idea. But we'll see. And I realize that in in a large organization of 110,000 people, that's not really an answer, but this is a question that bedevils all of us when it comes up.
Does
There
it
he goes.
need to does it need to scale
There he
is
goes.
kind of the question nobody asks. But
Yeah.
I'll leave it at that.
Well, I think it comes when we think of the whole system, like there's the technical system. What are we building? If we're doing rocket science, building rockets, and then there's the business side, like Tiani was talking about, the problems with how we fund things and what our charge numbers are and everything. And that's just crazy. But that makes up the whole system. There's the business side, there's the technical side, and there's the folks that are in charge of execution. And then in a large system, there's the layers of hierarchy, and there's always someone who's asking what a best practice is. And those words like probably make a lot. Yeah, I see people laughing. Like it's like it makes us cringe because, but in their role, that's the question they want answered. Well, if we figured it out over here, why can't we just apply it over here? Because they're trying to, and so I feel like part of my job, and probably it sounds like a lot of you, is to work with those people as well to help them to understand. And I think that's where my head was going. I mean, anticipating some of the questions that are going to be asked and some of the, and like, how do you have those conversations coming from the perspective that that person is coming from, with the expectations that are on them and what they're supposed to be doing. Yeah, so it's complex.
I like that Greg dropped in the chat that best practice is someone's past practice. And I kind of think of those as these sort of like, dusty artifacts that are brought out and said, this is how you do this. And everyone's like, okay, we'll give it a shot.
Right.
So.
Well, best practices exist. They're just way, way overused.
Yeah.
Because remember, and here's the why, because that sounds like a nonsensical statement, but it goes back to a little bit about what Marissa was saying is you've got systems and multiple layers of systems within systems within systems, and go on and on and on. When we're talking about systems, what are we talking about? Which layer are we interested in? The problem of scaling is not only do you have adjacent systems, you have systems that are part of larger systems. Nobody ever really defines out what we mean by systems. Therefore, the whole conversation about scaling quickly becomes nonsensical. So that's all I was going to get.
Yep, that's a good point.
Yeah, and it's that Kyle brought up the whole question of like, scaling as when you how do you scale local optimization, right? Now, and I've been in organizations where it was like, all local optimization all the way down, and that was a disaster too. But there's a balance to be found in things that are optimized locally versus things that have to be optimized globally, and this whole best practice question on that scale. I mean, 110,000 people.
You're not implementing scaling, you're navigating that space.
Yeah.
I think would be the best way
I like
to put
those
it.
words.
Yeah. Okay, Andrew has his hand up.
Yeah.
Hello. I'm following up on the question that ended up being mine. To ask
I have a question about my question.
Yeah. So one of the things that I know we've talked about, and we've talked as a group about it, is this idea of higher order change or higher order character. So one of the problems that we run into a lot with organizational change is you go in and you help some kind of a functional group or domain learn something, right? And then they kind of take that learning through observation, emergent pattern recognition, things like that, and they create some kind of a change. It could be in the process, could be in design, product, any number of things. And then when they try to transfer that, they're often transferring the downstream product of that learning. And I'm interested, given your experience in doing this across different organizations and within organizations, instead of focusing on, kind of that downstream emergent understanding and change, if you can identify an organizational character of the learning process for what that change needs to be, and how much that, kind of working on that mesoscale of an organization to see across all of these different functional domains or groups, as you continue to kind of set up these constraint frameworks to help them recognize and learn. If you see patterns on that scale, and if you've done any work on kind of facilitating the character of organizational learning, as you kind of go across all these different domains, and if you've had success stories in identifying the organizational learning kind of character and utilizing that to help them escape some of the transfer issues that we often see in complexity.
Yeah. I feel like I have more failure than success on this, but only because of time, partially because of time. But so another thing I worked on before I was coaching the digital thread team is I worked with my teammate, my colleague Michael, and Jabe Bloom on observability for these. So basically, we were brought into the CTO office at UTC to help product development become cheaper and faster, basically. The buzzword, like everybody wants that. And our manager had a hypothesis that he had developed that stage gate system that was being used everywhere, whether it was research and development and product development, big programs. I think it was something called like Passport or something like that, where it was like all these reviews and documentation and like a lot of stuff with standard work woven into it. The idea was if we could streamline that, things will just get faster. And then the other thing was we can use agile ways of working everywhere. And then we need to come up with how do we help the research center? So that's where we tested the idea with the FAN team. So they can integrate new technologies and make that faster too. And all of that means if we can do all those little optimizations there, that means it's gonna work. And so my teammate and I were like, we don't think those are the answers. But what might be good is if we had a system where we could help the organization learn and notice using this concept of hunting for where the bottlenecks are, hunting for where things are out of balance. ODM, like having a muscle for with leaders and teams, developing the right sets of metrics for a particular audience, things to measure and pay attention to, and how to evolve them. And then we went to work on basically we had a couple of one set of measures was focused on flow, and I guess you could say paired metrics, so you could expose or reduce the effect of gaming. So like, for example, if you're measuring throughput, you might want to also look at variability of throughputs. Like you can see, do I deliver with some kind of like steady, in a steady way, or is it like wild, like sometimes nothing and sometimes a lot, like things like that. And then we focused another set of measures that was completely bespoke to the data that this organization collects on learning and making connection between these things that happened way downstream all the way through production, like escapes with it, like they called them escapes, to defects that went out into the customer or defects that were found during design, to like the workforce, like skills, liquidity, how people are learning, the work mix, how much continuous improvement work is being done versus like feature work versus rework. And that was based, some of that thinking was based, there's a white paper I found, it's called Nobody Gets Credit for Fixing Problems That Never Happen, which I like the title of that. And it describes this thing called like a performance trap. Basically, it's like the less time you spend on continuous improvement in the beginning, you're just build, go and build. You feel you have this rush of activity and a rush of accomplishment, but over time your performance declines because you haven't built anything in your system to help you learn, to help you change, to help you get feedback from like, did this solve the problem? Is this useful? Is this designed well to be from an engineering perspective, all that kind of stuff, or whatever, for your building that you're building. And so it seemed really high concept, but we quickly got 2 large programs interested. And they were like, we have people who know how to do Tableau. We have you two as like people who can coach, and we have these leaders and teams that we can work with. Let's do this. So we got to that point, and then something crazy happened. Like the CTO left mysteriously, and they shut that program down, even though we were literally like right there, got engagement. They're like, we see that this would be useful because we don't know what to measure. We measure everything, and we can like tie this to like all the stuff we're doing on this like value production. But then it also has like a lot of stuff baked into it that can help us, that can help leaders and teams. We can work with HR on some of this stuff. We can work with finance and some of this stuff. Like it was like this little pivotal area that where we could get this going, and it could unlock stuff in other places. So it was kind of like almost success, like some success and then some failure there based on like organizational, change and everything. But that's what we focus on: observability and learning and flow, and making those things visible and learning how to use them versus those like red, green, yellow schedule type metrics that were just everywhere but didn't tell them anything about what's wrong, what might be wrong. Because sometimes a measure doesn't tell you exactly what's wrong. It tells you like, let's go hunt over here. Something's out of balance with this thing, this area, this domain, this part of our process or something like that. Let's go hunt and dig there. We might still have to uncover some more things because of complex adaptive systems, but at least it gives you something to go off of.
Yeah, agree with that. Be careful about hunting though, because where you find it isn't often where it's originating. So you have to continue.
It's distant in time and space.
Yeah, you can really mess yourself up by just hunting for things. And that's it's not even what they do in TOC, really. But
yeah,
I like it in general of looking for bottlenecks or hunting for them. I like in general, that's a good thing.
Yeah. I mean, in this white paper, I think Barbara just dropped in, they make the point in here that where a problem happens is sometimes the root cause is different in time and space, which is like the point of doing current reality tree and using theory constraints. And so, for example, like if a defect happens, you might tend to like blame the person closest to it in that process or in that workflow, or who wrote the code, like whatever. But you might find like, wait a second, as a system, you don't have good training, or your equipment is faulty, or you have like these other things happening that are actually making it really hard for people to do the work and do it at the quality that they'd like to.
You can fall into the trap of root causes in complex systems too, which is kind of mentally a place that we've been trained to think that way. And again, it's a big, long philosophical debate as to whether there is root cause. Really depends on how you define root cause in complex systems, but it's
multiple usually.
They're, I call them contributing factors, but there's
contributing factors.
They have to happen in a certain order at a certain time with a certain intensity, blah 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 blah.
Yeah.
So that's complexity. That's what we talk about.
Yeah, that's the thing. You have to be aware of that. And the other thing is that even interventions, they're never really a point intervention. They're usually like a system of things you're going to play with to see what happens too. That's another thing to keep in mind as well.
Okay, we're coming up on the hour. Tiani is exhausted. Any final questions, comments before we wrap this up? Thanks you guys for hanging in with us. Tiani, I usually judge the success of these meetups by how many links I had to put in the chat, and so you're right up there. As I hunted for papers all over the place. But I want to say this was awesome. Thank you so much. Big round of applause. Yes, virtual and real time. And if I know you're going to be at Lean Agile Cambridge next month. Is it Cambridge?
Agile Cambridge, yeah. I'm basically take all the, like, you guys provided me with feedback basically through all these questions and discussions, like switching up my talk some more because I'm going to be presenting a similar thing there.
So those of you in England, and I'm looking at you, Greg, make your way to Agile Cambridge to hear Tiani give another iteration of this talk. Thank you so much, Tiani. Thank you so much. This was great. I learned a lot. Anti-patterns, yay. And you are always welcome. You know that. We love your work. We'd love to have you back anytime you have anything to talk about. Thank you to the audience. We have another speaker lined up for next month. Hopefully, Chris McDermott should be here sometime in mid-September to talk about social practice theory and complexity. So we hope you'll join us then. And thank you so much. We'll see you soon. Bye.
Thank you all.